and the force of the bolt. So we'll apply our conditions for static equilibrium. The conditions for static equilibrium say that the net torque, so the sum of the torque acting about the pivot, is equal to 0. So we'll fill in our torques from our table here. So the net torque is L times sine theta times T minus 0.80 meters times mass of the sine times G over 2 minus 0.60 meters times mass of the sine times gravity over 2 minus 0.50 meters times the mass of the post times G plus 0 equals 0. Let's see, we know almost everything here. We don't know T and we don't know theta. Let's ask if we could find theta. So let's look at a little bit of geometry to find our theta right there. In our picture, we know that the length of the post comes from here to here. That length is 1 meter long. We know that the tension, that cable, is attached to the wall by a string that's 1.2 meters long. And there's our wall right there. This is our angle theta. If we think about our geometry, our trigonometry, we see that 1 meter is adjacent to this angle, so cosine of theta equals 1 meter. The adjacent divided by the hypotenuse, 1.20 meters. So it means that theta is going to be the inverse cosine of 1 meter over 1.2 meters. When we do that in our calculator, we get an angle of 33.6 degrees. Okay, so now we know the angle to put in right here. Let's just ask what the rest of the numbers are. So the mass of the sine is, let's just look at what we're given. The mass of the sine is 10 kilograms. So 0.8 times the mass of the sine times G times 2. If we do that in our calculator, this part is 39.24. 0.6 times the mass of the sine times G times 2. So the sine is 10 kilograms, G is 9.81. Do this through the calculator and we get 29.43. And then the last part, 0.5 times the mass of the post. The post has a mass of 5 kilograms times G. Run this through the calculator and we get 24.525 here. And then for this part of the expression, L times sine theta, L is the length of the post, that's 1 meter. Sine theta is sine of 33.6. So we do 1 meter times sine of 33.6. And what does that give us? 1 times sine of 33.6 gives us 0.553. So now what we can do is solve our problem here. So each of these guys are negative. They'll become positive when they come to the other side. So 0.553 times t equals 39.24 plus 29.43 plus 24.525. So t equals all of these guys added up. That's 93.195 divided by 0.553 to give us a magnitude of tension of 168.4 newtons. To write our tension as a vector, we have to write it as an angle. So T equals 168, we'll round it to 3 sig figs, newtons, at an angle theta, which is 33.6 degrees above the negative x-axis. Okay, in the next part, we'll find the force due to the bolt.